What's going on, everybody? Johnny Bannon here with Trepa Technologies. And in today's video, we're going to be going over section 8.0001 of our CCNA live virtual training and our CCNA video course. This section is going to go over the basic security concepts. So we're going to get into stuff like the CIA Triad. What is a threat? What is a vulnerability? What is an exploit? And how do we do mitigation? So this is going to seem like a CompTIA Security Plus slide, but I swear it's not. This is network engineering, and this is security concepts that we need to understand as the future of network admins and engineers. So let's go ahead and get started. So on our agenda today, we're going to be going over some network security overview and then the basic security concepts. So like I already said, we're going to touch on the CIA Triad, and then we're also going to go over these definitions here: threats, vulnerabilities, exploits, and mitigations. So when we talk about threats, we're going to go over the different types of threats, whether that be the human element or software, or the different vectors that these threats are going to be used against us. What we mean by that is like, is it going to be a threat via email, a vishing attempt, or a phishing attempt? Then we're going to go over vulnerabilities. What is a vulnerability? How does it differ than an exploit? Because sometimes I notice students do get those confused, and it's okay. Sometimes the comprehension and what these words mean in the tech world may be a little different than what you're used to hearing just in everyday life. And then we're going to go over different mitigation techniques. So again, the comprehension of this term, this is coming straight from the CCNA exam objectives. When I think mitigation, I think of a security control that helps to try to prevent or mitigate damage or mitigate risk. But in the CCNA exam and the exam objectives, I believe mitigations can also equal just straight up prevention, which may be different than you might have learned in the CompTIA Security Plus or other cybersecurity certifications. But just bear with us, right? Sometimes these terms aren't always just black and white. Depending on what vendor, who you're talking to, what engineer, sometimes there will be overlap in what they mean. Does mitigation mean try to prevent, or does it mean complete prevention? So we're going to dive into that and the different mitigations. So with that being said, let's go ahead and get started. Okay, so network security overview. So as network engineers, it's very important that we understand why the increasing cybersecurity landscape is important for us, and it affects how we perform at our jobs and how we implement technology. A lot of times when we're talking about industries and business, they care about their bottom line. They want profit. They want to know how the technology they're spending, because sometimes it can be millions, enables the business to make more money. So sometimes cybersecurity will sit on the back burner. And then the age-old thing happens. They have a security breach, they have a data breach, and all of a sudden, now cybersecurity is on the forefront. And then as network admins, we'll have to adjust to that. So now, network professionals are expected to understand the fundamentals of security concepts, the fundamentals of cybersecurity, where they sit on the incident response team. They're responsible for implementing layer 2, 3, and 4 security controls, logical and technical controls. And they should be expected, especially for that senior network engineer, to give, let's say, some advice, or to kind of make sure when they're sitting in that meeting, understand just the entire landscape and where their team, their sections, and where they fit in. Now we even see sometimes the NOC and the SOC working together, especially in a DevSecOps or DevOps environment. So it's very important that for our future as network engineers, that we don't take cybersecurity lightly, that we understand the concepts and we understand where our role sits. Because on a typical enterprise nowadays, I mean, you have so much network access control, whether that be at the layer 2, layer 3. Every switch I've worked on always has had some port security, either 802.1x, some network access control. They've also had always VLAN, some private VLANs, DHCP snooping, dynamic ARP inspection to stop some of these man-in-the-middle attacks. So it is something that we've been doing as network engineers and security professionals, but now it's just more prevalent. And in the CCNA exam, it's becoming a lot more prevalent that network engineers and admins just don't do switching and routing anymore. We got to understand the full breadth of the full stack of our full enterprise, okay? So again, also, we've always had VPN technologies. We've always done IPsec, crypto map tunnels, and it's been our job to ensure that those VPN tunnels stay up, which again is a security concept. So the first security concept we're going to go over is the CIA Triad. So the CIA Triad, this is always talked about when it comes to cybersecurity and the fundamentals, and it's really the basis for how cybersecurity professionals implement technologies, create policies, create SOPs, and how they create incident response plans. So the three acronyms, or the acronyms, right? CIA stands for confidentiality, integrity, availability. So quickly, we're going to summarize confidentiality on this slide. This is encryption. So this is encryption for data at rest, data in transit, and also data in use, but more or less as a network engineer, we're going to be worried about data at rest and data in transit. So, encryption. Do not get this confused with integrity and hashing and non-repudiation. This means that we turn our data from plain text into cipher text. And if we go through the history of encryption, humans have been doing this for a long time with just some basic like the Caesar encryption or cipher suite. We've been doing ciphers and encryption forever. Back in World War II, we had the Native American tribe that did encryption on our radio communications, right? And the Morse code. So encryption's always been around, and it's no different today, except a lot more robust, and the algorithms are a lot more robust. So some of the encryption algorithms we use, right? AES, RSA, also always known as SSH. We have TLS, SSL, and these are going to be cipher suites that are built on top or built with encryption to give our data confidentiality, okay? We also, for our data in rest, have full disk encryption. We do this in our running configs when we do the line 5 or the secret command that gives us that level 5 or line 5 encryption, right? So confidentiality deals with making sure our plain text becomes ciphertext. And now to talk about integrity. This is going to ensure that our data has not been changed or tampered with. So this always confuses my students when I'm teaching security. This is not encryption. This is not making sure that our data is not readable. This is making sure that our data has not been changed. So we see integrity solutions using hashing, digital certificates or signatures, really digital certificates. They use hashing, and they also deliver something called non-repudiation. So, with integrity, this is something that we could see in, during incident response, where when we start that chain of custody on the potentially exploited system, the first thing we want to do is obviously dump all our volatile information, and then start taking hashes of our drives and of the image. So we know that when the digital forensics team comes in, or maybe law enforcement, we do our chain of custody, they can verify that hash to make sure the data has not been changed. In just everyday life, when we're, let's say, installing files offline, typically the vendor or whoever the company is that's providing that software will provide a checksum or some digital hashes that you can compare against before installing that software. So we'll do a quick example with that in a little bonus lab. And then availability. I love talking about this to my students, availability. Why is that? Because sometimes as technicians, when we start training ourselves, we get super smart, we learn all these new technologies, we're so good at cybersecurity, we forget the whole point of business, and that is to make a profit. So, availability ensures that confidentiality and integrity don't take over and make our systems so hard to use that our users or our employees don't even want to use our systems. They can't get no work done. So availability ensures that there's high uptime with our systems, there's ease of use, and seamless connectivity. So now let's go on to our next slides where we kind of dive a little bit more into confidentiality and the CIA Triad. So again, confidentiality is going to protect sensitive information from unauthorized access to disclosure, essentially meaning again that our plain text and ciphertext, and if you don't have our key, you won't be able to decrypt our information. Along with this, just to talk about it, we're not going to dive deep into it. There's something called asymmetric and symmetric encryption, where symmetric uses a single private or secret key, and asymmetric uses key pairs. So that's going to be a public and private key pair that are mathematically linked that can only encrypt and decrypt each other. And I say this because it's protecting sensitive information from unauthorized access or disclosure, meaning that if I'm encrypting with AES and I created a private key to do that, if no one has my private key, they can never decrypt it. So unless you're authorized to decrypt it, you won't ever be able to see what my data is. It's going to be in ciphertext, right? So confidentiality, that's where you implement encryption and access controls to maintain data confidentiality. And then again, ensure only authorized individuals can access those confidential data or resources. Okay, integrity. So this is going to prevent unauthorized modification or alteration of data. So again, this is going over hashing, making sure that none of our data or our software has been changed. We can implement data validation and checksums to maintain that data integrity. And we can protect against data corruption or unauthorized tampering. This is kind of when we're talking about that chain of custody. In the case of a cybersecurity incident, we want to make sure that we take hashes every time that a piece of compromised hardware moves from one person or entity to another. And that includes law enforcement. Okay, and then availability. This ensures timely and uninterrupted access to resources for authorized users, meaning that our systems are highly available, easy to use, and makes it easy for our employees to work on our enterprise, and makes it easy for our users to access our product or whatever resources we're delivering to the public. So with availability, we want to make sure that we're implementing redundancy. We have disaster recovery plans. So this is getting into like the BCP, which is the business continuity plan. This is getting into the DRP, disaster recovery plan. This is going over how we would do a COOP, which is a continuation of services, right? So, with availability, you have to make sure that you always have your systems highly available, okay? Or excuse me, this stands for continuation of operations. So a COOP, that's when you maybe go from your main data center and you migrate to your backup data center. This is going to go over something called hot sites, warm sites, and cold sites. Going over cloud-based versus on-prem backups. So with availability, it's not just making sure that, hey, our share portal, it has great latency. It's making sure that in case of disaster, that those systems and resources are still available. And this also goes into things that sometimes we forget, like power. Do we have brownouts or blackouts? Do we have sufficient ups or generators and an ATS switch in place? How do we do data deduplication or duplication? Do we have RAID configure on our servers? Do we have actual hot sites that have been tested? Have we put in a time to come down and over to our redundant site? So availability as a network admin can also be something as simple as an FHRP, a first hop redundancy protocol. Maybe this is us creating EEM scripts to create or go to our backup tunnels if we have 3 forms of transport. This is definitely one of the big pluses for SD-WAN, where we can have a broadband, a 5G, an MPLS, a dedicated circuit, and a Starlink connection, 5 different forms of transport with an SD-WAN configuration and software-defined WAN. We can have high availability of accessing the internet and out to the ISP, right? So, availability, you can probably tell this is my favorite thing to talk about when we're talking about the CIA Triad. So with availability, we're trying to mitigate system failures, disruptions, and also attacks to preserve resource availability. This also goes into incident response and the incident response plan, IRP. What are we going to do when there's an incident and maybe a computer's infected? Are we putting it in an isolated or private VLAN? Are we going to shut off that switch? Are we going to kill that trunk so it can't spread? Do we have span or RSpan configured so we can see and actually do that Wireshark or packet capture? So this is going to be very important in my book and very important in your everyday life as a network admin and engineer. So that is the CIA Triad. Now let's get into more security concepts in our next video. I don't want to make the video too long, everybody, so we're at the 15-minute mark. It's perfect. So stay tuned when we go over our next section, and that is security concepts, where we talk about threats, exploits, and vulnerabilities. Thank you.